So welcome to the learning series. So we're actually reviewing the new exam that came out July 15th of 2025. So today we're going to cover section 5 in two sections. The first one will be 5.1 to 5.7, and then the other one will be the remaining questions. So the way it's situated is the actual exam question is on the left-hand side. A summary of the material is on the right-hand side, and anything that's new will be in bold. Also, what's new is the block and formula diagrams that you can study on and take in with the exam. So, they have a study aid and a reference material. So the study aid is something like this, where they give you a formula and they actually explain the formula in words, or they may give you a diagram. So this you can use as a study aid. You can't take this particular one into the exam. And here's a typical HF installation. And here's the material that you can take into the exam. So they give you the formulas, but they don't explain it to you. Or they give you the diagrams, but they don't label what it is and what these individual components are. So, so in this case, because we're covering electricity today,
Oh,
so
really?
the form, yes,
Um, I think we should not say that we can take into the exam because from an examiner's standpoint, I prefer the students not to bring anything, but they will be provided with those resource material sheets along
okay,
with the exam.
yeah, that'll be another 5 pages that you have to print out
That's
for each
fine.
exam.
I'm
Yes,
okay with that because
we
I
will
prefer them
provide.
not to bring anything.
Yeah, okay, that's fine.
So anyways, just point of clarification.
Yeah, so we'll print out these study aids and they'll be part of the exam.
Otherwise, we would have to check everything they bring in, right?
Yeah.
Yeah, yeah.
So, okay.
So in this case, the reference study aid will be useful because we are going to talk about Ohm's law and power today. So these are the formulas. Oops, I'm going the wrong way. And these are also the formulas for resistance in parallel and in series, and capacitors and inductors in series and parallel. So that would be useful too for the exam. So we're up to section 5 now. So we're going to cover electricity components and measurements. So in the first half, we're going to cover the metric system, electricity, power circuits, Ohm's law, series parallel resistors, power, and frequency. And then we'll cover the rest in the next section coming up. The one section that has changed quite a bit is 11 transformers. The rest relatively has remained the same, although there have been some new questions added. So starting off here, when you need to know the metric system, so you either have to multiply by 1,000 or divide by 1,000, except for one question. So in this case, we're going from megahertz to kilohertz. So in this case, you have to multiply by 1,000, so the answer is B. Here's another question, converting 3,000 milliamps to amps. So in this question, you're going to have to divide by 1,000. So 3,000 divided by 1,000 is 3 amps. So C is the correct answer. Here, how many hertz in a kilohertz? So remember, kilo is 1,000. So the answer is going to be D, 1,000. So B, so the next one, how many microfarads in a million picofarads? So in this case, this is the one where you're going to have to multiply. So you're going to get the answer B, 1 microfarad. So this is the only exception where you don't multiply or divide by 1,000. Here, if you have a handheld transceiver that puts out 500 milliwatts, how many watts that is. So in this case, you're going to have to divide by 1,000. So 500 divided by 1,000 is 0.5 watts. So C is the correct answer. Here's another question. A kilo ohm is how many ohms? So in this case, you have to multiply by 1,000. So 1 kilo ohm is 1,000 ohms. So A is the correct answer. How many megahertz in 7,040 kilohertz? So in this case, you have to divide by 1,000. So that gives you 7.04 megahertz. A is the correct answer. Here is another question. So we have 1/4 of an amp. So 1/4 of an amp is 0.25 of an amp. So in this case, it's you're going to have to multiply by 1,000. So the answer is 250 milliamps. Here is another question. How many millivolts equals 2 volts? So here you have to multiply by 1,000. So 2 times 1,000 is 2,000 millivolts. So C is the correct answer. Here's a new question. Here they're asking you to convert from megahertz to gigahertz. So in this case, to do that, you would have to divide by 1,000. So down here is the new question. How many millihenries equals 10,000 microhenries? So here you have to divide by 1,000. So 10,000 divided by 1,000 is 10 millihenries. So D is the correct answer. So that concludes the conversions. There'll be more conversions as part of some of the Ohm's law questions, but this is strictly the section on the metric system. So which group listed below are good electrical conductors? So that would be anything that is metal. So in this case, A would be the correct answer, gold, silver, and aluminum. Here's a similar question. What is a good insulator? So we're looking for something that's not a metal. So in this case, the answer would be B, glass, air, and porcelain. Here is a new question. What do you call the flow of electrical charge in a circuit? So that the flow of electrical charge would be current. So C is the correct answer. Which is the best conductor among the following materials? So in this case, copper would be the best one. Copper is better than aluminum, and then these other ones are either semiconductors or like a resistor. Which type of materials readily allows the flow of electric current? So a conductor allows the flow of electric current. So A is the correct answer. What electrical property causes an object to conduct electricity very well? So something that has low resistance would conduct electricity. So A is the correct answer. What is the symbol R for? So R is for resistance. So B is the correct answer. What is the inverse of resistance? So that's 1 over R. So 1 over R is conductance. A is the correct answer. What is a voltage drop? So when you look at this, the best answer here is the loss of voltage caused by a flow of current through a circuit. So C is the correct answer. The resistance of a conductor changes with, so that would be temperature. D. Here's a new question. What term describes the direction of current in a DC circuit? So that would be polarity. So now we get on to power and circuits. So which term describes the rate at which electrical energy is used? And that would be now power. D would be the correct answer. If you have light bulbs marked 40 watts, 50 watts, 60 watts, and 100 watts, which one will consume electrical energy at the highest rate? So here you're looking for the highest wattage, which would be 100 watts. So B is the correct answer, 100 watts. What is the basic unit of electrical power? So that would be the watt. A is the correct answer. A circuit consists of a battery and load resistor. What circuit malfunction would cause no current to be drawn from the battery? So in this case, there's no current flowing, so you have an open circuit. So A would be the correct answer. What electrical circuit draws too much current? So in this case, you would have you're drawing too much current, so you would have a short circuit. So D would be the correct answer. So here's another question relating to power. Power is expressed in watts, so watts is the correct answer, B. Which of the following two quantities should be multiplied together to find power? So remember the equation P equals I times E, so pi. So it would be voltage times current. So B would be the correct answer. Which two electrical units multiplied together gives the unit watts? So similar to this question. So here it would be volts times amps. So C is the correct answer. A resistor in a circuit becomes very hot and starts to burn. This is because the resistor is dissipating too much, and that would be too much power. So the resistor is underrated and becomes hot and could burn out. Here's a new question. When speaking of electrical circuits, what does the term continuity mean? So some of the newer meters that you have a continuity checker on it. So that means that when you use a continuity checker, it's like a buzzer. So it's checking for a closed circuit. So B is the correct answer. So there's continuity in the circuit you're measuring. Another new question. You've acquired a transceiver that's connected to a power supply. When you switch on the power supply, its fuse blows immediately. What circuit malfunction caused the fuse to blow? So most likely it would be a short circuit. So B is the correct answer. If everything was operating properly, the fuse shouldn't blow. Now we get into Ohm's law. So Ohm's law is E equals I times R, or you can divide both sides and get different forms of it. So here's a question. What is the voltage across a 2 ohm resistor that draws 0.5 amps of current? So here you would multiply the two, here you would divide. No, sorry, you would multiply the two together. And so the answer would be a 1 volt. How is the current in a DC circuit calculated when the voltage and resistance are known? So you look at the Ohm's law. So current is calculated by taking the voltage and dividing it by R. So A is the correct answer. How is the resistance in a DC circuit calculated when the voltage and current is known? So you take this formula, you divide both sides by I, and you get R equals E divided by I. So the correct answer would be C. Resistance equals voltage divided by current. Here's another question. How is the voltage in a DC circuit calculated when the current and resistance are known? So here you would have to multiply the two together. E equals I times R. So voltage equals current multiplied by resistance. Some more calculations for you. What is the resistance of a circuit that draws 0.25 amps with a 12-volt source? So again, here you're looking for resistance. So you take 12 volts and divide it by 0.25. So D would be the correct answer, which is 48 ohms. Another question, what is the value of resistance required to drop 9 volts with a current of 10 milliamps? So remember here, 10 milliamps, you have to convert to amps before you do the calculation. You have to convert this to a base unit and then plug it into the formula. So A would be the correct answer, which would be 900 ohms. If a current flowing through a 50 ohm resistor is 0.44 amps, what is the voltage you need to measure across the resistor? So here again, it's E equals I times R. So 50 times 0.44 is 22 volts. So B is the correct answer. A 30 ohm resistor is connected across a 6-volt battery. What current flows through it? So here you're taking 30 divided by 6. So D is the correct answer, 0.2. What voltage is needed to supply a current of 200 milliamps to operate a relay that has a resistance of 25 ohms? So here, remember again, 200 milliamps, you're going to have to convert this to amps and then do the calculation. So the correct answer is C, 5 volts. What formula calculates the resistance of a circuit where voltage and current are known? So that would be R equals E divided by I. So D would be the correct answer. What is the resistance of a circuit that draws 300 milliamps from a 3-volt battery? Remember again, 300 milliamps, you have to convert into amps and then plug it into the formula. So C is the correct answer, which is 10 ohms. Now we're getting into series and parallel resistors. So in a parallel circuit, the voltage source and several branch resistors, but how is the total current related to the current in the branch resistors? So remember here, you're in a parallel circuit. So the total current is the sum of the branch currents. So B would be the correct answer. If you connect 400 ohm resistors in parallel across a 12-volt battery, how many milliamps of current are drawn from the battery? So in this case, you have to calculate the total resistance. So 100, so this is 4 resistors, so 100 divided by 4 would be 25 ohms. And then you've got a 12-volt battery. But here, that will give you the answer in amps. So then you would have to convert it into milliamps. So C would be the correct answer, which would be 480 milliamps. So several resistors of various values are connected together in parallel. How does the total resistance of the combination compare to the individual resistors? So in this case, it's less than the smallest resistor value. So D is the correct answer. 2,000 ohm resistors are connected in parallel across a 12-volt battery. What is the current? So again, you have to take the 2 resistors in parallel. So that would be 1,000 divided by 2, that's 500 ohms and 12 volts. But remember, they want milliamps. So you're going to have to convert your answer into milliamps. So the correct answer is C. The total resistance of resistors connected in series. So in this case, it's greater than the resistance of any one resistor. So here, what is the total resistance of 5 10-ohm resistors in series? So in this case, you would just add them up. So 10 plus 10 plus 10 plus 10 plus 10. So it would be 50 ohms. Which of these series combination of resistors would replace a single 120 ohm resistor? So remember in series, so 5 times 24 would give you 120 ohms. If 10 resistors of equal value R are wired in parallel, what formula equals the total resistance? So if all the values are the same, so it's R divided by 10, so D is the correct answer. What is the total resistance of 4 60-ohm resistors in parallel? So again, here you take 68 and divide it by 4. So B would be the correct answer, 17 ohms. Two resistors in parallel. Resistor A carries twice the current of resistor B, which means that, and you'll have to look at the Ohm's law when you do this. So C is the correct answer. A is half the resistance of B because it carries twice the current. At the total current in the parallel circuit is equal to, so the sum of the current through all the parallel branches. So you have to add up each branch to get you the total current. Now we're getting into power. So why would a large size resistor be used instead of a smaller one for the same resistance value? And that's because you want greater power dissipation. So you use, so C is the correct answer. A load requires 12 volts DC at 5 amps. What is the minimum required power transformer rating? So here you have to calculate power. So P equals I times E. So that's 12 times 5, which would be 60 watts. So C is the correct answer. What is the DC input power of a transmitter operating at 12 volts and drawing 500 milliamps? So here, what you have to do is convert the 500 milliamps into amps, and then multiply it by 12. So that would be B, 6 watts. When two 500 ohm 1 watt resistors are connected in series, the maximum total power that can be displaced by the resistors is. So in this case, because each resistor is 1 watt and you have two of them, the answer would be 2 watts. So B. When two 500 1 watt resistors are collected in parallel, they can dissipate a total power of, in this case, again, it would be 2 watts because you have two resistors connected together. If a voltage applied to two resistors in series is doubled, how much will the total power change? So this would be increased by 4 times. So because the voltage goes up 2 times, power goes up by 4 times. Which of these combination of resistors could make a 50 ohm dummy load that can safely dissipate 5 watts? So what you want to do is, first of all, calculate that you have 50 ohms, and then also make sure it can handle 5 watts. So A would be the correct answer. So you have four 200 watt resistors in parallel. So 200 divided by 4 gives you 50 ohms. And because you have 4 resistors of 2 watt each, it can handle 8 watts. How much current is drawn by a 12 volt 30 watt light bulb? So using the formula here, just remember I equals P divided by E. So then you divide these 30 by 12 and gives you D, which is 2.5 amps. What is the power consumption of two 10 ohm resistors connected in series with a 10 volt battery? So here you have to calculate the R first. So since it's series, it's 10 plus 10, 20 ohms and a 10 volt battery. So you would calculate the current and then you would calculate the power. So B would be the correct answer, which would be 5 watts. What is the advantage of replacing a 50 ohm resistor with a parallel combination of 200 ohm resistors of the same power rating. So same resistance, but greater power rating. So B would be the correct answer. Resistor wattage ratings are. So it's determined by the heat dissipation qualities of the resistor. So C is the correct answer. Now we get into frequency and AC. So what is the term for the number of times per second of alternating current that completes a positive to negative cycle? So cycles per second was the old term that was used for frequency. So A would be the correct answer, frequency. So here is one of the questions. So what is the approximate range of frequency that a human can hear? So A is the correct answer, 20 hertz to 20,000 hertz. What is the range of frequencies from 20 hertz to 20 kilohertz termed audio frequency? Why is it termed that? Because this is the range that the human ear can hear, can sense sound. So C is the correct answer. Electrical energy at a frequency of 7,125 kilohertz is in what frequency range? So this would be in the HF range. So B is the correct answer, which would be HF. So HF covers 3 megahertz to 30 megahertz. What is the name for the distance an AC signal travels during one complete cycle? So that is the wavelength. So D is the correct answer. What happens to the signal's wavelength as the frequency increases? So these are reciprocal of each other. So as the frequency increases, the wavelength decreases. So B is the correct answer. What happens to a signal's frequency as the wavelength gets shorter? So as it gets shorter, the frequency increases. So B is the correct answer. What does 60 hertz mean? So that means 60 cycles per second. Here's a new question. Two AC waveforms have the same frequency, but their cycles do not begin at the same instance. What term describes the timing difference? So when you look at this on an oscilloscope, they would not be lined up properly. So the difference between the two would be a phase. What happens to a signal frequency as its wavelengths get shorter? So as it gets shorter, it the opposite for is that it increases. So remember, frequency and wavelength are reciprocals of each other. Didn't we just do this one? No, okay. What does 60 hertz mean? 60 cycles per second. Oh, okay. Okay, sorry, I was going backwards. No wonder. What is the shape of a waveform of the electricity supplied from a household receptacle? So that would be a sine wave coming out. So D is the correct answer. A signal is composed of a fundamental frequency of 2 kilohertz and another of 4 kilohertz. What is the name given to the 4 kilohertz signal? So if it's multiple of the primary frequency, it's known as a harmonic. So B is the correct answer. So that completes this part. So let me just stop the recording.